मुख्यమైన కారణం ఏంటంటే ప్రపంచానికి ఏర్పడింది నేను సాధారణ కారణం. So gravitational waves is a property of the universe, not of the object in the universe, and that is the reason why we still see gravitational waves are not light from the matter.
Wondering that when you give a sort of metaphorical take on how the universe is communicating to us through gravitational waves, and as popularized by one of the recent movies, Interstellar, of course that's science fiction, but it also had this one concept of how the protagonist conveyed to his daughter messages through gravity, and at that time the entire world was skeptical about how this could be possible. But since the discovery of gravitational waves has made it possible, is there any scope for such communication in the future?
Interstellar is written by Kip Thorne, my advisor's advisor, and that is why in the film the robot in his honor is called Kip. So Kip wrote this film because he always complained कि कोई सारी science fiction movie बनती नहीं है, and whenever you make science fiction you so much violate the laws of physics. So he decided he's going to write a script. And starting instead of NASA we had LIGO detectors there. But then we said that LIGO अगर gravitational wave detect नहीं करे तो आगे चलेगा लोग तो movie नहीं जोड़े. So he decided they're going to use NASA instead. And you ask, so in the film there is an instance where the father is in future, the daughter is in past, and he is able to communicate through gravitational waves. And yes, that is possible. I would not be able to explain as good as maybe Kip Thorne if he was present would be, but that is absolutely possible that you can go past in time and send signals using gravitational waves.
Numerous ways to control it. I mean, to use it for the betterment of the mankind, right?
Yes.
So I want to ask, have you thought about any ways that you can control gravitational waves for the betterment of the mankind?
Yes. Future students have to take up the field of gravitational waves. So our mission was simple. Our mission was to prove gravitational waves exist or not. And that mission took us 100 years. I'm talking about Maharaj अनेकों PhD student. Kip Thorne जेव्हा scientist जे science 70 वर्ष ना life ना आखा process पण करिया. And we have not won out yet, but a lot of people now, our mission was simple. We have to detect gravitational waves and we have to tell you a little more about it. कि gravitational wave कई speed है आवे, क्या की आवे, क्या है ना तो मैं शू करी सकता हूँ. The future application is in the arena outside.
I wanted to ask whether you can control gravitational waves.
We cannot, because gravity cannot be shielded. It's not easy. At least we don't understand. It's a very important thing to understand. कि universe में कोई पर force होए ना, तमें ने रोकी शको. तमें भीतो बनाने light रोकी शको. तमें concrete ना ये बनाने nuclear radiation रोकी शको. पर तमें वो कशु ना बनाई शको, जिना कारण तमें gravity ना रोकी शको. No matter where you are, if there is an object heavier than you are gonna be attracted to it. And we have not understood how to shield gravity yet. Maybe there are ideas. कि अगर हम एक direction में fast जाता हो, जिस direction में gravity करने खींचे से, then there is a balance, and you can create applications that way. Maybe yes.
It's about Einstein theory. He also stated that if we travel at the speed of light, then our time will stay still. That is, if we travel at the age of 20 and we travel at the speed of light, we will be 20 only, that is, we won't die. And so how did he explain that? You must have heard the story of Jack and Jill. Jack and Jill went up the hill, Jack broke his crown, and there is something more to it, that a spaceship came and some aliens abducted Jill. And the age of both was 7 years old, and after 20 years the aliens thought that we should leave Jill again on the planet Earth. So the age of Jack was 27 years after 7 plus 20, but the age of Jill was just 17. Yes. Because the spaceship was traveling at the 80% speed of the light.
Yes. Okay.
So how did Einstein explain that?
Who are मारो best friend, right? हमें बंदे same age ना अच्छे. And at the age of 10, he decides to go up all the way up, satellite pass. इंटरनेशनल स्पेस स्टेशन જે હતા. And we play this game કે તારા ઘડિયાળની 5 સેકન્ડ થાય ત્યારે તને ઉપરથી મારા પર એક ટેનિસ બોલ ફેંકવાનો, રાઈટ? સો પહેલો બોલ એને ફેંક્યો, સેકન્ડ બોલ એને પાછો 5 સેકન્ડ પછી ફેંક્યો, પછીથી ત્રીજો બોલ પાછો 5 સેકન્ડ પછી ફેંક્યો, એટલે ટોટલ 3 બોલ થઈ ગયા 15 સેકન્ડમાં. And now the balls are coming down. But because એ ગ્રેવિટીમાં આવે છે એટલે એની સ્પીડ વધી જાય. એટલે પહેલો બોલ મને જેવો મળ્યો એટલે મારી ઘડિયાળ ચાલુ થઈ, ઓકે. પછી બીજો બોલ આવ્યો, પણ બીજો બોલ તો 3 સેકન્ડમાં નીકળ્યો. કેમ? કારણ કે તરત વધારે સ્પીડથી ખેંચાયો, રાઈટ? એના પછીનો ત્રીજો બોલ પણ 3 સેકન્ડમાં જ આવે. કેમ? કારણ કે ગ્રેવિટી તો સરખી જ છે ઉપર. સો મને 6 સેકન્ડમાં 3 બોલ આવ્યા, જ્યારે ઉપરથી મારા ફ્રેન્ડે 15 સેકન્ડમાં 3 બોલ ફેંક્યા. સો વોટ હેપન્સ કે હું જ્યારે 3 વર્ષનો થઈશ ત્યારે એ 15 વર્ષનો થઈ જશે, રાઈટ? ઇવન ઇફ વી બોથ એગ્રી કે અમે સેમ જ ટાઈમે બોલ ફેંકવાના છે ને આખું મેજરમેન્ટ કર્યું. This is called the twin paradox in general relativity. And this is something which we have measured and it actually happens.
That means time on Earth is traveling different and time in universe is traveling differently.
Yes.
Is that the meaning?
Yes, exactly. Different parts in universe travel at different speed.
Okay, thank you. First of all, congratulations for being on a trajectory that includes Nobel Prize as well as cities to be named after you. So my question is that after you made this LIGO project, you got this wave, right? Now we know that universe is very vast, and even researchers says that there is one massive black hole in the center of Milky Way.
Yes.
So now this thing that you measured happened around 150 crore years ago. So shouldn't you be getting this data every minute? Because considering the vastness of this universe, this event might happen like every minute, but at different positions in the universe.
And that's the key point, different positions in the universe. Because different position in the universe means different amplitude of the signal. કારણ કે કઈ વસ્તુ મારી બાજુમાં થાય, અગર બે બ્લેક હોલ થાય તો પણ આપણા રૂમમાં કોઈ નથી રહેવાના, પણ એ જ બ્લેક હોલ ઘણા દૂર હોય તો એના 1 over distance square energy drop થાય. That's why your signal amplitude drops around you. Now why don't we see it in Milky Way galaxy? જ્યાં already આપણા 1000 કરોડ તારા છે, 1000 કરોડ તારા બ્લેક હોલમાં પડી ગયા છે, અને એમાંથી કેમ નથી થતું? કારણ કે બે બ્લેક હોલ જ્યારે એકબીજાની આજુબાજુ ફરે છે તો કેટલા વખત સુધી ફરે? મિલિયન યર સુધી. અને પછી ફાઇનલી જ્યારે એકદમ નજીક આવે છે, ખાલી 5 છેલ્લી ઓર્બિટ બાકી હોય ત્યારે લોકો ભટકાય અને it becomes a gravitational wave that we can detect. So the answer is that there are already black holes. અને લોકો અત્યારે એટલા બધા દૂર છે કે their probability કે લોકો એકબીજા સાથે અથડાશે within 1 year is less than the probability that you are going to be hit by an asteroid while you are alive.
It's in the theory of relativity. If a person is on aboard the ISS and a person is on Earth, so the person on the ISS is going to age faster than the person on Earth. But we also know that the Earth is moving at a fast speed around the Sun, and the Sun itself is also moving around it, around the Milky Way. And even the Milky Way might be revolving around the Sun.
Yes, absolutely. So every different thing, so
Every single thing will move at a every single thing will also age at different rates. So
yes, that's true. A satellite, what is the closest gravity that we see is Earth? So अगर તમે જ્યારે સેટેલાઇટ પર હો ત્યારે તમને અર્થની જે ગ્રેવિટી ફીલ થાય છે, it is much more than the gravity caused by sun when you are there. So because of that, the time that you are going to have on Earth and you are going to have on satellite is completely irrespective of whether sun exists or not, if you are combining the two. Right? And that is the reason why, so I'm just going to possibly end on a slight controversial point. So this is a good question in the sense why, આખું બ્રહ્માંડ એકની આજુબાજુમાં બધું ફરી રહ્યું છે, ચંદ્ર અહીંયા છે, પૃથ્વી ત્યાં છે, બીજા પ્લેનેટ્સ છે. But does those planets really affect us? જ્યારે આપણે કહીએ કે શનિ ભારે પડ્યું, does it really? Does it happen actually? કારણ કે તમે આટલું ફિઝિક્સ શીખ્યા બાદ, તમે બ્લેક હોલનું પોઝિશન શોધ્યા બાદ, you can calculate કે તમને માર્સની ગ્રેવિટી જે તમને અડકે અર્થ પર એ કેટલી છે. And there's a classic 12th science of physics problem actually. You have an object and you want to make any gravity to that. And you measure the contour for an electricity effect. This fan can affect your life much more than any planet in our solar system.
Do gravitational waves share similar features to light waves in the sense that can you polarize them, or
Yes.
do they have a spectrum,
Yes.
or can they be subjected to Doppler shifts?
Yes, to both. You can see right now is 10 hertz to 1000 hertz. So if you are in a lower spectrum, you have to go on the space.
And what about Doppler shifts? They are also
They also get Doppler shift.
I think we can all give him a standing ovation. Every member of the audience who has had some curiosity about space and physics and astrophysics in particular, we cannot thank you enough for your wonderful interaction and talk. It was not only lucid, you put very complex physics, astrophysics into very simple words like Anuradha said for us. What was also very nice, and if we are not used to it at all of us, is to hear somebody talk at this level, with this much amount of work and research. His talk splattered with so much Gujarati. So that is another positive. Which probably has touched each one of us. This talk for us would be memorable, Karan, not only for the work you have done, but because it is done by somebody who grew up in our city, grew up as one of us, as one of all of you students who I heard who asked such interesting questions. And Karan, you have taken us on a journey which I'm sure these younger students will take forward. The questions they ask indicates the amount of curiosity, amount of understanding they have, and thank you for sharing your talk with us, because I think this is the maximum and the most valuable return that scientists like you can make to mankind. You know, where you are able to share your work coming out of your laboratories, out of your absolutely focused areas, coming down to the level that we can understand your work or understand the phenomena which governs us and the space and the whole cosmos, and instill in our young generation enough curiosity that they take up work like you have and take our understanding of the universe and its impact and the various applications, useful applications that there will be from this kind of research in the decades, I do not say years, but definitely decades to come. Thank you very much. I have to thank Barubai Shukla, I don't know if he's still here. Barubai, thank you so much for bringing Karan Jani to Navrachna, and I do hope that you will come back again. I know that you are talking all across the country at very prestigious institutes to scientists and to lay people like us, but you are a Barodian and we will demand your time. I wish the LIGO project in India all the success. It's very, very again prestigious that you have been chosen to kind of lead it, at least till the year itself, and become part of a team which will win a Nobel Prize someday. So take up that challenge. So many questions for which we have a better understanding through the answers that you gave. So many questions which will be answered through research and discoveries in the future years. I will end with what Stephen Hawking had said in his autobiography. You know, when he was asked that, and he said about so many things, about the future and physics and the mathematics and all of that. He said that astrophysics, after a point,